So one of the main applications of strain gauges is when they're used within force and torque sensors. All right, so the force measurements are very important. In terms of weight, typically it's used a lot of times to quantify forces or weights. All right, so in those type of applications, one of the major pieces of equipment that is used to determine what is the applied force or the weight of an object is something that's called a load cell. All right, so any device that converts an applied force to a voltage or electrical signal is considered to be a load cell. All right, so typically there's two major ways that this is often done. It can be done via strain gauges, which is the most common type, and then also some load cells have piezoelectric elements that charge up when they're under load. So we'll talk about these briefly below. All right. So there are a few different types of strain gauge load cells. All right, you can have strain gauge load cells that are based in compression or flexion. So these are axial load cells. All right, so they measure the strain along the axis of this column. All right, and then there's other load cells that measure bending loads, or shear loads, and those are called like flexure load cells. Okay, all load cells are typically designed to measure forces within a given range. Okay, so there's typically low capacity load cells that might be able to measure forces that are like 100 grams, for example. All right, while higher capacity load cells can measure like tons of forces. All right, so depending on the, the range of forces that you want to do, you should pick a load cell that is suitable for that. All right, so typically load cells are designed so that the strain gauges are sense only forces in a desired direction. All right, so we're not interested in measuring a lot. We're trying to isolate the strains within a given direction to record those. We don't want to have like Poisson's effects and other things playing an effect in our measurement. All right, so all right, there's I would say the most common type of strain gauge load cells are the bending beam load cell. All right, which is cheap. All right. So an example of the bending beam load cell is shown here, where we have a cantilever, we have a fixed end of our beam of our bending beam load cell. We apply a load at one end, all right, and we measure the strain gauges on the top and bottom of that beam, and we get the stress from that. All right. The second type of load cell would be a strain gauge, a shear stress load cell. So again, very similarly, um, we have a shear force being applied here, but instead of measuring um, the shear stress, so instead of measuring the normal stress on the top of the and bottom surface, we actually measure the shear stress the inside on the center of the beam. So if we use an I-beam, for example, we know that the maximum shear stress will occur at the center line. All right, and because it's an I-beam, the width of the beam is the smallest in the middle, so we'll get very large strains in the center of the I-beam, so it'll give us higher strains, which will give us better sensitivity than if we had a solid rectangular cross section. Okay, um, so in addition to the strain gauge load cells, we talk about piezoelectric load cells are typically made out of single crystalline quartz, and they develop charge under strain, and then we can convert that charge to a voltage proportional. And if we know the relationship between the charge and the voltage, we can determine what would be the strain and the charge. And we know the relationship between the charge and the voltage. We can correspond that voltage reading with the amount of strain within the load cell.